this series of webinars are organized by Participatory Modeling Community of Practice with support of our Dutch colleagues, Deltares. The community of practice is literally an international community of professionals and researchers, and some of you you belong to this community. Happy to see familiar faces, and welcome to the others. So basically, this is a community of professionals and researchers who are striving for synergies between public participation and diverse modeling methods. And we know that participatory modeling is an umbrella term that includes diverse levels of participation as well as diverse modeling tools, starting from something relatively simple as mind maps and ending with something very sophisticated as quantitative simulation models. But what unites it all is this aim of creating an environment where stakeholders can learn, gain shared understanding of complex problems. We believe that this is the solid basis for further action-oriented outcomes. So these webinars is the initiative, our initiative to introduce the diversity of participatory modeling methods to the professionals and researchers working with communities. And today's topic is dedicated to a particular participatory modeling approach, participatory mapping. And our today's speaker, Dr. Nagesh Kolagani from Centurion University in India, is a unique professional who has a very well-balanced experience, including both in theory and in practice. He has extensive experience of using GIS tools for community engagement and particularly working with farming communities in rural India. So keeping in mind this unique experience of our speaker, we decided to have two workshops. One is the introductory workshop. We are here now, and another one is going to be a hands-on workshop which will take place next week on Saturday, 9th of October, and there you can have hands-on experience of using some of GIS tools that can be applied in community-related practices. So before handing it over to Nagesh, I just want to give you a bit of information about housekeeping. So we will have questions and answer session in the end, but also feel free to write your questions in the chat. And during the questions and answer sessions, of course, you can ask questions by switching on your microphone. However, in the meanwhile, I would kindly ask you to mute your microphone so that we don't have any noises or disturbances. So again, thanks a lot for joining us. And Nagesh, I'm handing it over to you. The floor is yours.
Elena, I switch back to computer. Can you remake me as a host?
Sure. Just a second. Now it should be working.
Okay. Yeah. Can you see my screen, Elena?
Yes, it works. Thanks.
Yeah. Okay. So, yeah. So my topic is accounting. That is income expenditure of natural resources. How, why we need involvement of stakeholders, and how mapping can help in the process, and what tools exist. So as Elena mentioned, this is part of a series of webinars, Participatory Modeling Community of Practice and Deltares, both of them I thank for this opportunity. Yeah, so first what I'll do is I'll spend a few slides on the need, why I think there is a need for accounting. And then I'll give a case study in my project village in South India, where we have tried it. With water as an example, a domain. Then I'll go through the tools GIS as well as remote sensing, which is about satellite imagery primarily. And these tools will be just a preview of what I intend to elaborate in the longer workshop next month, in a few weeks from now. So need for natural resource accounting. So first is, if you say natural resources, to my mind, three things come in mind in Indian language: Jal, Jungle, Zameen. So forest, water, and land, soil. So for example, this is my project village. You can see towards the west, the left side of the map, this is all forest. The streams originate in the forest. They bring water, and they are impounded by these water bodies. And these water bodies typically form a chain, one after another, there will be water bodies. Now, as these forests get degraded, 50 years back, till 60s, 70s, they were reasonably thickly forested, at least till the 40s, 50s. Now, all that is left is thorny scrub jungle. I go to those forests, there is no topsoil left at all for any tree to grow. Only acacia, desert kind of plants can grow in those trees. So what happened to all the topsoil? All that has come along these streams and deposited in these water bodies. For example, this is a bund that these are the hills I'm talking about, the forest. You can see that they're quite, I don't know if you can notice, they're quite degraded. There's no vegetation there. You go there and you will see about 3 feet height or 5 feet height of thorny scrub jungle. There's no topsoil. It will be almost like rock, the soil, the land. All the topsoil has got washed and it fills up these water bodies. Now, two damages. One is the forest is gone. Second is the capacity of the water body to hold water also comes down substantially. For example, you walk on this water bund. Typically, the way you create a water body is you dig upstream of the water body, scoop the earth and deposit as the bund so that it adds to your water capacity. So when you walk on the water bund, you expect the upstream to be far deeper than the downstream. Whereas if you walk on this water bund, downstream, this height is about 20 feet, upstream will barely be 10 feet. So that much of siltation has taken place, and no government program. The government does try a lot of desilting of these water bodies, but nothing can match the amount of silt that has come over decades. So it's a loss of forest, lots of water bodies, and slowly this degradation that they've started on the forest, it comes in the hills, comes down to the valley also. So for example, here, this area used to be full of sugarcane. Okay, so for example, this is how it used to be. It's the same bund that you see at the back. You could never see the bund. Whereas now, it has totally got, there's no water to grow sugarcane anymore. It's either fallow or they are growing low income millet kind of crops. This is jowar, sorghum, I don't know what it is called, some kind of a millet. And there's peanut, groundnut. Right? These are rain-fed crops. Now, and this is the case, looks like throughout the world, right? Throughout the world, regions that have sustainable groundwater balance. I like the word balance that they are also using, this IWMI 2000 paper. Anyway, so, and now if you ask farmers what the cause is, first, what is the cause? The water table is falling. In the 90s, it was 50 feet until the 80s, late 80s. Then when I went in 95, it was 250 feet. By 2000, it reached 400, and very quickly it fell to 600 feet. And after that, we hit the hard rock. So you can drill as deep as you want. You only get rock powder. You don't get water anymore. Okay. Now you go to farmers and you ask them, okay, they know all this data. They are very smart and quite savvy, data savvy also. Now you ask them, they say less rains. It seems reasonably intuitive, except, during the 90s, 92, 96, 98, there were good rain years. Whereas after that, only 2005 and 15, Otherwise, in between, there were no good rain years. So they say, this crisis is all because of the climate change. Rains have stopped coming. Now, is that true? How do you know? So the moment you say rains are low, what you need to do is increase recharge. You start building more water bodies so that whatever drop falls, it is retained there. And go one step further like Israel, and where you say, I don't want to let the water go even into the earth. I want to put a plastic sheet and hold it right there and prevent evaporation. No percolation into the ground, no evapotranspiration. I hold it as it is. So now that is something that the contractors love. For example, Government of India has spent every year, it spends about, I don't know if I'm correct with my numbers, 5,000 crore Indian rupees. So that to me looked like $1 billion US, but I need to cross check. And typically things work government suboptimally by its own admission. Less than 30% is like 30% is like a very efficient structure. So you can imagine the kind of wastage, and farmers are okay with it because it's not their money, it's government money, and contractors are very happy. So everything gets directed towards recharge, improving recharge. But let us say you try to fill a pot with a hole. Will you ever be able to fill it? No. You have to control the expenditure, and that nobody wants to talk because it's politically sensitive. And that's where participatory modeling comes. So you need to get people involved and try to get them they already know the facts. Try to help them see the situation that this kind of recharge increase is not going to help them. So that is where I feel there is a need for participatory natural resource accounting. In this particular case, water accounting. Okay, to increase the sense of ownership. Unless people own it, government is never going to step in and talk about decreased discharge. It will always talk about increasing recharge, and which is never going to solve, because whatever water you save is going to be immediately sucked up. Okay, so and how do you plan to control discharge? If people agree, if they can, sharing might be too socialist utopia. At least trading. Instead of I wasting my water, can I sell it to somebody in a mutually beneficial way? And how do I transport water across the village for sale? So I might have to lay a pipeline to transport water from one place to another. If there were no roads, would citizens build their own roads to go from one house to another? No. Same way, government can come in and lay pipelines to help transport water. These are the kind of things appropriate to local context that might come up when we do participatory water accounting, participatory modeling, etc. And mapping, a picture is worth 1,000 words or something like that is being said. So participatory mapping, natural resource accounting is how I feel, in my experience, is useful, and in the experience of so many people who have reported in papers. I'll just go through quickly the thing that I have tried nearly a decade or two back. So for example, until 70s, as I told you, this is forest area to the west of my village. The streams bring water. Red line, this boundary is my village with all farms inside. This is the low-lying area where the open wells used to be, in the low-lying area. This water body used to impound water. And these are farms that used to be directly irrigated by the water body, whereas each of these wells would irrigate 2-3 acres of land around the well. Now, in 70s, we had only open wells, and cattle used to be, livestock used to be used to pull the water from the well. There was no other power source. There was no diesel, no electricity. That came about in the 80s. And immediately, as soon as electricity and deep tube wells came, you can see the number of increase in wells. We went around and saw each of them with a few farmers. We collected their longitude, latitude information, etc. We mapped it. So you can see the count has gone up from 76 or so to 198. Number of wells has gone up. And as you can see, previously all the open wells used to be in the low-lying area here. Now tube well doesn't differentiate. Even on the top of a hill, you can dig a tube well. As long as you hit the correct vein, you will get water. That is the geomorphology of my area. So there is some kind of a typically the richer people used to be in the low-lying areas because they were the first settlers. The poorer people used to be on the upper ridges. And to that extent, there is redistribution equity because now water is available to these poorer farmers also. But that was at the expense of the ecology, sustainability. Now, if you see the calculations, in the 70s, output used to be by a bullock. It could only work a few hours a day. It can only draw so much per hour. Number of hours has increased. No, 3 times. A tube well is about typically 7.5 to 10 horsepower. So, which is about 3 times more than a pair of bullocks. The number of hours also has increased 1.5 times. That is, power is not 24 hours. Luckily, it was only 8 hours a day or so due to limited electricity available. Number of wells has increased. Together, you can see the 80s and 90s have witnessed one order of magnitude amount of sucking out of water from the ground, whereas the recharge has remained the same. So unless you control discharge, there is no point going on increasing recharge, and you cannot really go beyond too much because finally it is the rain that decides how much water you get, and no water is leaving this village. So whatever you put a new structure, you are only distributing water within the village. You are not stopping anything from going outside because nothing was going out since 2001. So, and if you do one kind of a thumb rule estimate of discharge to recharge, you can see in the past it was same order of magnitude, 2/3 discharge by recharge. Whereas in the 80s and 90s, it went up by one order of magnitude, almost 8 times. So if your expenses, household expenditure is 8 times your income, how long will your reserves last? So that is what exactly happened, and this is what caused this water table to fall from 50 feet to 600 feet. And this is not just failure of rains. That could be a part of the reason, but more important reason is for 20 years you have been consuming 10 times more than what you are getting, and that is the cause, which they kind of knew, but these kind of figures, when they stare at them, they tend to appreciate them better. That is where I feel this accounting will help in educating people, and that will hopefully eventually lead to better politicians coming up, hopefully, and making better decisions, because people are ready to accept that. It's not that they are dumb, it's just that they are playing to the whatever is attractive to the people. Elena, can you hear me?
Yeah, we can. Yeah, no.
Yeah. Okay. My presentation was stuck. So what has happened is, by the time 2001 came, we hit the 600 feet. We couldn't go any deeper, and then suddenly the whole bubble burst all of a sudden. Till then, people were thinking, okay, we'll keep going down. It will cost more money, but we can at least get water. Whereas the moment you hit the hard rock, you can drill deeper, but you won't get any water. And the number crashed suddenly to 59. From 76, you went up to 198, and suddenly the number crashed down to only 59 were working. Some of them in the low-lying area, some of them in the upper area. So all that has happened in the 80s and 90s is, at the end, is the same number almost, except they're now redistributed. Now, what about the cost? So where we are in 2000 is almost same as where we were in 70s, except instead of drawing water in an ecological way using cattle, now we have replaced it with all these costly tube wells. Each farmer has sunk so many rupees in sinking them. And electricity cost is paid by the government, free electricity for political reasons. So it's a recurring cost, which it was free before in the 70s, drawing that water using bullocks. Free, in a bullock sense. Whereas now it is costly, recurring cost the government loses. Actually, if this price the farmer has to pay, he won't farm. There was a proposal to give the free coupons so that instead of consuming electricity, they could sell the coupons. And that way, at least the resource won't be wasted. But then there were political reasons why that got scuttled, because then they can't fudge the accounts. because all the electricity stolen used to be built on the farmers, saying it's the electricity, etc. So now those are the calculations we made in 2002. Now recently 2015 we revisited those accounts, and 2015 I told you earlier that there were very good rain. Just before that, the whole area was totally parched. There was no drinking water also. Okay. Whereas even during that crisis time, before the rains also, we calculated how many wells were working. 17 were working reasonably well. 6 were working okay. 12 were barely working. Okay, you can see the count: 17, 29, 35. And if you see the amount of water that is being pulled out was roughly same as what we were getting in the 70s also. So the assumption by the farmers saying that the rains have really gone down doesn't go well. It is not that the rainwater has come down drastically. Yes, it has come down to an extent, but it is that the discharge is the main problem. That's what must be addressed. Till then, no amount of, you can pump any number of crores, the contractors will become richer, those who make those structures, but not the farmers. And that is becoming obvious now. Nobody under 50 years of age stays in the village. I'm told it is a very similar scenario in US also. 2018, IIM's lecture, there was a keynote speaker. So now, what do we do about it? So basically, what these people here are trying to do is they are trying to look at a map, Google map, and trying to see if we can lay a village-wide pipeline, how much it could cost, so that people could sell water across. So for example, I am in this corner. My neighbors are not ready to pay for water around me, from me, whereas somebody down here might be willing. But then how do I transport my water from there to here? I can't lay a pipeline. It won't be economically justifiable. Whereas if there's a grid, then I could use that grid, pipeline grid, to put my water into the grid, and this person can collect it, and he can pay me. So those kind of deals is what informally were going on in some way, but that's what we are trying to formalize and push for. These are the kind of things that I feel will come out of water accounting, participatory, based on the local condition. Now, participatory mapping, what are the kind of technologies? So I come from a software engineering background. I try to simplify and take them to people so that school children can use them, and their parents, semi-literate parents, can use the tools, whereas the data can be gathered by the school children and educated youth, etc. So I will explain briefly the various tools that I know about. And these, if any of you are interested during the workshop, I'll explain in more detail and in a hands-on way, where I'll make you do through various tasks. So it's the same, it improves visualization, understanding, participation. My own experience is in a matter of 2 to 4 hours, they can realign themselves to Google Earth imagery. They can trace where their farm is, how they will go from their house to their farm. They get comfortable and start dictating. Not actually using the tools, especially the semi-literate ones, but at least they can understand maps. So what we have done is, we have put together a mobile app that gathers data. That data, if you have internet, you can upload it to a server, and it will make the maps, processes, and dishes out maps. Or you can connect it to a local small netbook, which is portable, and people can see those maps. Typically, you need an LCD projector to project. That's what we were using. We bought one LCD projector. So this is the kind of spatial planning of village development activities. Typically in India, every year you get so much money to spend in the village. Before money is sanctioned to you, you are supposed to tell what all structures you are going to do. Typically what happens, it's a last minute exercise. They just say, yes, we have visited all the areas. We want 18 check dams and 20 water bodies, etc. Without visiting, they would write. Now, when the money comes, they will go in last minute and try to do wherever they can do low cost and to their benefit. Whereas, if you ask them for a map and where you have to at planning stage, if you have to exactly tell which forces you to go there. So one is, and the neighbors will be involved, and it becomes more participatory. I feel a map forces you to become more participatory. So some of the farmers will go, some won't go. When you come back and present, more people will attend. So we can discuss these after much negotiation. You can tag these with photographs and audio clips, etc. And hopefully the plan that comes out will be far more representative, democratic. Then it will never be 100%. It will at least help improve uh, the equitable nature of the plan. So this is just zoomed in version of those maps. So you can see the Google Earth imagery on which the proposed structures and existing water bodies, etc., are overlaid. I can click this farm and see whose farm it is. I can click this and see the photographs, etc. So as I said, I click here, I get to see the photographs, I click through them, and audio clips. When you go in the field audio transcription, you just record in the audio, and when you come back, you can play it and type up the fields, because in the field to fill the fields would be difficult. And the data collection effort, instead of GIS experts coming in, we went with a simple mobile app. So let's say they want to map a road. So there's an icon with a road. And of course, it has some text here that says road. You can click that. It will send, or give option to note locations. As you walk along the road, you can keep clicking, etc. So these typically middle school children are able to teach, able to map, collect data. These are their school teachers. It's important to get involve the school teachers. And finally, when they come back, they connect to computers and they pull one menu item, prepare map. All these points that they have walked and collected will fall over on this. This was a little novel when we did this early 2010 or 11, 12. Now we have GeoODK, which is very good. And we can go with those tools also. Much better tools are also available now. This also we have made available. You can go to this folder here. And that folder has whatever software you can download and use also. Both the mobile APK as well as the Quantum GIS plugin. And then it's not enough. We conduct training workshops for school children, and they enjoy it. Anything that brings them out of their school into the field. As I said, this is all the work that we did around 2015 and before. And we also train NGO field workers. And that is what I want to restart now in an international sphere, in a voluntary spirit, so that we don't need to be stuck with the old tools that we have developed. We can even take the latest ones, some of which I'll show now. And in India or internationally, we can do crowdsourcing. And instead of relying on government data, macro or micro, we can actually crowdsource and give credit to people, the students, the teachers, the headmaster, etc. And try to put it up in an open data format is what I would like to do. I'm trying. So the next tool is what we have developed a few years back. So recently I got into Google Earth. All of you know about Google Earth. Then Quantum GIS I mentioned. I just mentioned those. That is B and C. The fourth one is what I'm recently, last 6 months, 1 year I have learned, is satellite imagery through Google Earth Engine. Earth Engine is different from Earth, so that also I'll explain. So Google Earth is, you don't have to go to the field to mark your farm. I can sit here, look at Google Earth, I can draw my boundary, I can talk to other farmers, draw boundaries of their farms, I can tag it with data, say, and I can finally export as KML files. And I can do the reverse also. The KML files can be imported into Quantum GIS. And after you work in Quantum GIS, you can export as shape files. Those can be imported. For example, this is district map of India overlaid on Google Map, Google Earth. Okay, so you can do to and fro. And so far, at least, it is free. How long it will stay free, we don't know. And when we do typically, 4 to 8 hour kind of workshops, we do hands-on tasks. So these are, from installation, we assume nothing, that the student, the participant doesn't know anything. So we make them start with installation. So they will be able to, georeference, measure, digitize forms, import them, convert KML, even generate them. All these are doable in a 4 to 8 hour window time frame. So these are the tasks we do, and we give assignments. And this is what we try to do about this Google Earth. Google Earth is a very useful tool. Most of you would have used it. Next is Quantum GIS. So this is free and it runs on your desktop. So we again build with installation, and we assume you are not, you should know Microsoft Office level of comfort level you should have. We cannot teach you file handling, mouse handling. Those we assume we know, you know. Other than that, we don't expect any technical background on your part. And these are the tasks we go through, from installation to printing maps for showing to people. And then we make you do a mini project that uses Google Earth and Quantum GIS. So zoom to your project village, save a georeference image of your, then you bring it into Quantum GIS, georeference it, propose where you want to put up structures, etc. And then you take it back to Google Earth, again come back to Quantum GIS and generate a project file, and these are the submissions. So hopefully in an 8 hour time frame, we can do this. This is what we do with Google Earth and Quantum GIS. The more recent thing that I am enamored with, but this is high-end Python programming. Those who want to make Quantum GIS even more user-friendly, you can develop plugins using Python. That I don't expect to teach or anybody to learn, except programmers who want to take this forward. It is quite easy to do, and in the workshop 2, in a second workshop, we can possibly do that. What I am, another thing that I am reasonably, I got into recently, I told you, is what is called, this is not Google Earth, it is Earth Engine. Okay, so typically, I don't know how many of you would have looked at satellite imagery. When I began about a year back, so there is this European satellite imagery freely available. Every 15 days, all of Earth is mapped at 10-meter resolution, and it's all free. And you can download from Europe Space Agency website, or you can download the same from US website. But then when you do, you download as 700 MB scans, very large, kilometers by kilometers is a minimum you need to download. If I want to study this small water body, I need to download 700 MB. And then when I came across Earth Engine, I was really impressed. All that I needed to do was I just say, I define a rectangle, right? I say, these are the 4 corners of my rectangle of interest. Okay. And then I will say, please get me European imagery. Just a few kilobytes. You just tell which space you want. These are the 4 coordinates, and you tell which source you want. So, for example, Sentinel European data, or US data, Landsat, or IRS from India. Okay, and then you say which time frame, window. So you can say summer of 2020, from 2 dates you can mention. It will immediately get you and show you the list of images that are available. You can choose the one and it will display. Okay, now it does one more. All this happens in about 5 lines of code. Currently, you have to write those 5 lines of code. What I typically do is I give these 5 lines of code and expect people to change the numbers. In the next iteration, I plan to give a GUI. It will come up as a dialog box. You just need to enter those numbers. I have not done that yet. Now, what is more is you can actually classify. What I did is, so I went around and I said, vegetation, water, built up area, that is roads and buildings. So wherever I see vegetation, I put a small polygon. I know this is vegetation, I know this is vegetation, etc. I tell the computer that look, these are all vegetations. I tell the computer I drew 10 such polygons, vegetation, 10 polygons. Wherever I knew there was water, I drew 10 polygons there. And I said, look, that is water. That's how water looks in a satellite image. Then I went to around 11 roads and buildings. I said, this is how built up area looks. And based on that, the computer visits the whole area and paints it as built up area, vegetation, and water body. And it's reasonably accurate assessment. These stray noises, some of them you can ignore. Some of them might be true. If it is showing such a large green patch, it definitely must be some vegetation there. Whereas these could be mistakes, we don't know. But you can see it as roughly caught the water body, roughly caught where the water is within that, etc. All this is automated. And the kind of code that is this, just 2, 3, 4 lines that I show you here, even these we are trying to say not required. So actually, I have ended much faster than I planned. Elena, I'm done.
That's great, Nagesh. Thanks a lot for your presentation. So yeah, now we're gonna have questions and answers session. So if anyone has a question, please feel free to unmute yourself and ask the question.
Just to get things going, Nagesh, could you kindly explain some of the units that you were using? There was CUM per hour. What does CUM mean?
Oh, cubic meters.
Cubic meter. Okay,
Yeah.
got it. And the other thing which was a little bit mysterious for me was the numbers which were like 15, 15, 000.
Just 1 second. Can you see my screen?
Yes.
Okay.
What
Where is that?
Yeah. Just like this one, the one that you just skipped.
So basically,
Like 218, 880. What does that mean?
what is that? Say again, please, Alexei.
Discharge in cubic meters per year, 2,18, 880. What is this?
Okay. So
How
basically,
do you read this number?
yeah. So what we did is, in a year, I want to see how much water is being drawn out from the earth in my village, right? So I say, how many wells do you have? Do you have about 76 wells? Into how many hours do you work each of those wells? 76 into 720. Number of hours per year, right? So how did I come across this 720 is justified some area here. I didn't put a refer. You see the 120 days per year into 6 hours per day is 720. You see at the bottom, Alexei, bottom right? Yeah. Okay. So I say so many wells you have, so many days you work, and you use those wells, so many hours per day, and every hour that you work, how many liters or cubic meters you pull out. I think 1 cubic meter is like 1,000 liters. Alexei, I'm not sure. I need to check. Okay.
Okay.
So,
so the number here, does it mean 2,018,880? Is this how you read it?
right. I'm sorry, because in India, 1/10 of a million is a lakh. So it is 218.
Okay, that's where it gets confusing. Yes.
Right. Yeah. And these numbers are all kind of thumb rule. I sat with people and I will say, for example, how did I come up with this number 4 or 12.2? So we actually took a pot and saw how long it takes to fill it with a tube well. So 4 seconds. Then, okay, we extrapolated. This is how we have computed these. 200 liters, whereas bullocks, every trip they go, they collect 200 liters into one trip per 3 minutes, etc.
Okay, thank you.
Yeah.
Yes, please.
And Nagesh, I also have a question for you. So I was curious to know, like, what's your vision? How these GIS tools can be used in the context of the city and urban problems. So what are your ideas on that.
What is that? Urban problems, and what is the other one?
I was asking how GIS tools that you were talking about can be used in the context of city problems. As previously you were talking, like we were talking about village and rural areas, and I'm asking about cities. Do you have any like vision about that?
Yeah. So cities, I am sorry, our pronunciations mismatch. Sorry. For example, recently in the state that I live in, Tamil Nadu state, it has got a sanction of 700 primary health centers, right? These are free, unlike the West doesn't know free, at least US doesn't know. So in India, government runs a lot of health centers where medicines and doctors are freely available to the citizens. So, and who goes there? The poor people go. Okay, and currently there are 400 health centers in urban health centers in Tamil Nadu state. They have budget for opening 300 more. Now, sadly, ideally you should locate where your main customers are, the poor people are, the slums are. Typically, they are not located that way. So they want to extensively use GIS to locate where are our people, where are our slums, and where are our 400 health centers. We can't move them. At least the 300 new ones that we open, can we locate them reasonably close to their potential clientele?
Mm-hmm.
So, for example, health GIS is something location-based services. Locating services is one of the things where GIS can be used, and locating urban health centers for the government is something that I can immediately think about. Is then planning bus routes. Let us say schools. There are lots of government schools that are open. So where is our clientele? So just like a water body, you can draw catchment. I can also draw catchment of where my students are coming from.
Mm-hmm.
And open new schools, gap area analysis, all these you can do. Whatever typically a commercial agency does, they use extensively GIS to locate their new banking outlets. So financial centers, health centers, bus routes, all this can be done using GIS.
Mm-hmm. Yeah, thanks. These are really great examples. Yeah. Is there any other questions from the audience?
Yes, here, Beatrice, I have a question. Well, I have several questions. Thank you very much for the presentation. Firstly, you talked about this GIS worker or these NGO field workers. And were they helping to do, did you educate them to help the villagers to work with this GIS? Or did it work without any?
Yeah, so there are two kinds of trainings. One is these school children or NGO workers, for them to go around and gather data and make map, it will take at least 5 days of training. Typically, in one day they pick it up, but they'll forget. Again, second day they have to repeat. Collect data, make a map. Collect data, make. Unless they do it at least 3 times, by second day they get a feel of it. Third day it gets into their head. Fourth day they do a project. So it takes 5 days of training. Typically our workshops, you see the children here, middle school. It takes about 5 days of training, and we involve the school teachers also and local politicians. So 5-day training they need for collecting data and making maps. Data collection and map preparation. It will take that much, even after simplification, everything. Whereas when you gather farmers like this and you show these maps, you cannot expect to train them. It has to be on the fly. They should just be able to see this map and just understand in about half an hour, 1 hour, and they do typically. So we don't train this. So for example, he is a illiterate person, he is semi-literate. So they take to it quite well. We don't train them. So for their utilization, there is no training. For map preparation, data collection, there is extensive training, 5-day training.
So the idea is that the school children will work with the farmers then to do this.
So typically, it is a parent-child. Let us say you survey my farm. When an outsider comes and surveys my farm, I don't take him seriously. Believe, Whereas when my own child surveys and says, "Yeah, it is correct," otherwise I don't understand what that fellow is walking around with a mobile and saying. It becomes all this land is a very disputed item in the villages. So the parent-child is typically the school children, and parent is the semi-literate farmer typically. So the trust factor also gets addressed because of this.
Very smart way of arranging it, organizing it. And then for this national data base or national mapping idea that you have or project.
Yeah, this is a scaling up. Go on, please.
Yes. Are you working together with the government somehow on this, or are you doing it just as a free thing that you try to implement together with the really local level, or?
No, so this needs to be taken up with funding agencies. So because you need to have some kind of reward, and you need to hold national competitions, and the best school. Everybody needs to be given ego boosting as well as. So unless national level, I'm not got this started. I proposed NGOs who can go to funding agencies and do it, so that I can advise and facilitate, but it has not taken off. This is still at a proposal stage.
Okay, but have you talked also to any governmental bodies or authority experts and so on?
I am doing it, but it is currently, I act through my NGO friends, and I get them to take it up so that they have more energy and bandwidth to do this. For example, one of our participants is a major NGO from India here, WOTR, whom I met through Alexi now recently. So they are people with much better bandwidth who are already in this space, who are doing great work. So I hope to work with them together so that I learn from them, and hopefully I'll also benefit them in some way. Yeah, that is my model. But I look forward to a time when crowdsourcing of data goes on, and planning goes based on that crowdsourced data instead of some fudged and garbage in, garbage out kind of data.
It's interesting to think of how these things can be scaled up.
Yeah. Yeah, but scaling up is not easy. I don't say I've done it, and it's a very big challenge, and I hope the NGOs know how to do it. I'll work with water and other agencies, hopefully, in the next 5-10 years.
But there's so much to win from it.
Yeah.
So, yes, thank you.
Yeah, thanks.
Any other questions? Thank you, Beatrice.
So any real problems that you see? Any bottlenecks? What should we be aware of?
So actually, data preparation, 5 days we have kind of solved, but I think this data utilization, we need to work far more and simplify so that people can use them much more. So that is one big challenge, and scaling up is other big challenge. It's so for example, I know one NGO, they do all this, they prepare the maps, Then I used to try with LCD projector, laptop, all that. They dumped all that. They started printing very big flexi maps, very big 10 feet by 10 feet map. And that map they will take to the village. Then everybody is very comfortable. The moment you don't see a screen, you are very happy. So you put it on the floor. This is your Google Earth image of your village. Now you start asking them, where do you want your school to be? Where you want your new water bodies to be? And they start participating. And so these new means have to be explored. And so data utilization is a big challenge. Preparation we can always address technically. Yeah, I don't know if I've addressed your question, Alexi, but on the utilization side is the main challenge, and that's where I would like to scale up and see, work with other organizations.
Well, internet connectivity seems to be like a must.
No, that's what in the diagram I showed you. These days in India it is there, but this is if you want internet connectivity is if you want to go this route. If you go this route, there's just a cable to your laptop. You collect data with your mobile and mobile maps using satellite connectivity, which is not, you don't need a SIM card. You take a mobile, throw out the SIM card also, it will work. Because the satellites are NavSat or the Russian or the American satellites are there, even Indian ones are coming up, and you directly just connect it through a cable to your computer and you can make a map. This internet is only mainly to share data with your funding agency, this route. You can go directly. Was that clear, Alexi?
Yes, thank you.
You don't need internet, yeah. You don't need internet, you don't need cellular connectivity, mobile connectivity either.
Excellent.
All that you need is a clear sky so that satellite and your mobile device can communicate, or a Garmin device.
Yes, Beatrice, I can see that.
Yes, and no, sorry.
Question. Yeah. Please.
Yes, this mobile app, Village Keys, is that available?
Yeah, so this PPT we will share somehow to you. If you see this link given below here at the bottom, if I go there, I don't know if I can go there, but if I go there, it will be a folder, it's APK, everything is there. Yeah. But as I said, I have not mentioned here, there is a tool called GeoODK. That is also quite popular and powerful.
Sorry, what was it called? The other.
GeoODK is for collecting data in the field on tap questionnaires. GeoODK makes it possible to connect location-based data also. I have not used it much, but anyway, whatever I have done is available free here. I was just suggesting that anybody here can also try GeoODK apart from what I am giving.
How do you spell that? GEO
for GeoODK. Open Data Kit.
Open Data
Kit, KIT Kit. ODK. Anyway, I will, I'll add that also and update the PPT.
Okay, since the link is not clickable on the presentation, I think it would be best if we just copy it to our website, where we will be also posting the video of this webinar.
Yeah.
And then people can just directly go to the Google Drive to download the.
Yeah.
Yes.
Yes, before the workshop, next time we meet, should we download this Google Earth Pro and QGIS?
Yeah, what I will do is I will prepare a one-page note on what you can come prepared to, very detailed, so that in case I need you to do anything before, like downloading, I will tell you in that sheet, Beatrice. Okay, I'll do that. That's a good suggestion, Elena. I'll do that.
Thank you.
So that we don't waste download time when we meet.
Okay, sounds great. So any other questions? If there is any, there is a chance to ask them. In the meanwhile, I believe we look forward to see and to join the hands-on workshop. And there will be additional reminder to your email with the link to the meeting, to the Zoom meeting. So if there is no more questions, then Nagesh, I'd like to thank you a lot for your presentation. And thanks to everyone else for joining and for your great questions. And we look forward to see you at the hands-on workshops.